Advanced Math, Lesson 39, Part B, is about different forms of linear equations. And the book makes mention of families of lines, so we're starting out with that, and then we'll get right into the different forms. We actually use families for some of our problems. A family of lines is a group of lines, or a set of lines, that share a common characteristic. So there's some characteristic they have in common. Character. Like the slope, for instance. So let's say we had here, make it easy, a line with slope 1, right through the origin. There are many other lines that also have a slope of 1, that just happen to have different y-intercepts. Okay, and we could keep going. That would be a family of lines. They all have the same slope because they are parallel. Okay, they might also, not also, but instead have the same y-intercept. So we'll make the y-intercept 2. There's a line with the y-intercept of 2. Here's a line with the y-intercept of 2. And so on. You can make as many of these as you wish, but they all share that feature. They all have that feature in common. And so this one happens to be same y-intercept. Okay, the ones with the same slope we have been using in the problems because when you know the slope of one line, then you know the slope of all the other lines in that family. You just need to find out what the y-intercept is for the other line. Okay, and we have pretty exclusively been using slope-intercept form for quite some time now, but there are other forms that are very useful for certain applications, and they're listed down here. The general form and standard form are very similar. Just which one it is depends on which side of the equal sign the constant is on. And for both of those, for the general and the standard, there are a few stipulations. And this works for both of them. I was just going to write it over here. A, B, and C are integers. So there it is in math symbols. They're an element of the integers. Okay, so you might want to just write that they're integers. No fractions or decimals. Okay, also the GCF of A, B, and C is 1, which means they don't all divide evenly by the same thing. If they do, you'd have to do that when you're simplifying your answer. And then the only other requirement is A is greater than or equal to 0. A is not negative. Okay, no fractions or decimals. They don't all divide by the same thing. And A is not negative. Okay, that is for general and standard. They're the only ones on here that are using the capital letters, and that's what these are going with. Okay, slope-intercept, you're very familiar with. M is the slope, B is the y-intercept. Double intercept, or a lot of people just call it intercept, that form is always x over some number plus y over some number equals 1. And this number is the x-intercept. It's where the line crosses the x-axis. So the A is the x-intercept. And B is the same as this B. It's the y-intercept. I'm missing a parenthesis. Didn't notice that. Okay, so point slope. This one, this is m is the slope, just like in slope-intercept. And as the name implies, we have a point and we have the slope. So the point isn't necessarily the y-intercept. Here's the slope, and then the coordinates of the point we have go right in there. And just the plane y and the plane x, they're the letters you write. 2 point, okay, so if you have the coordinates of 2 points, you could put them right into this formula. Okay, this form of the equation. The plane x and the plane y, you actually write x and y, but the x1 and the y1, those are coordinates of one of the points, and then also the x2 and the y2. You see right in there, that's your slope formula. Okay, so when you put them into the slope formula, that can be part of the equation instead of figuring it out separately and putting it in as m. That's the only difference with that one. We're going to get some practice now in converting from one form to another. And like I said, there are different ones here useful for different applications. We're not going to be applying right now, just practicing changing from one form to another. So let's take a look. In example 6, okay, we're given one in slope-intercept form, and we're supposed to change it to general form. Okay, and general form is the one where the constant is on the left side. So that's what we're going to head for. That means, okay, let's go ahead and just add these things to that side. We could have just moved the y over also, but I'm going to do this. So add 7/3 x minus 1/5. It's kind of awkwardly written, but we have now, and we have to have it in like x, then y, then constant equals 0. So we have 7/3 x plus y minus 1/5 equals 0. Okay, now the rules were no fractions or decimals. Well, we've got fractions right now. So looking at these denominators, I see the LCM is 15, so that's what I'm multiplying every term in the equation by. Multiplying by 15. Okay, then 3 goes into 15 5 times. We have 35x plus 15y minus 3 equals 0. Okay, double check my calculations. I think that looks all right. Okay, now we don't have fractions or decimals. The GCF of all three of these numbers has to be 1. They can't all divide evenly by the same thing. These two both divide by 5, but that doesn't. These two both divide by 3, but that doesn't. So that's okay. As long as all three don't divide by the same thing, there's nothing to do. And the other thing is a, which is the coefficient of x, has to be positive. It is. This is the form. This is the one we wanted. That's all you do for these. Okay, so now we're going to take a look at example 7. Use the point slope form to find the equation of the line whose slope is -1/3 and that passes through -2, 5. Then transform it to general form. So we're going to start with point slope and then switch it to another form. Okay, so y minus 5, because that's the y coordinate, equals, and then for the slope, that was -1/3, and then that's times x minus the x coordinate, minus -2 is +2. Okay, so this is our point slope form of the equation. And now they want it switched to general again, which is the one we did in example 6. So we'll distribute, and then we'll get everything moved over to the one side. Y minus 5 equals negative 1/3 x minus 2/3. And then bring them over. We would have 1/3 x plus y. And then we have, I'm going to write minus 15/3 and add my 2/3. You could do this in more steps. I was just trying to be efficient. Okay, so add 1/3. Here's the y. I rewrote negative 5 as this because I was getting common denominators because I knew I'm adding 2/3. And I could have done that in my head, but I'd rather not do that because that's when I'm more likely to mess up. Okay, so we have 1/3 x plus y minus 13/3 equals 0. Okay, we have the x, then the y, then the constant equals 0. They're in the right order. But we have fractions again. So this time the LCM is just 3, so we're going to multiply everything by 3. Alright, so then we have x plus 3y minus 13 equals 0. They're in the right order. There aren't any fractions. They don't all divide by the same thing. And a is positive. It's a positive 1. So we're done again. One more. Okay, so in example 8, we are given the general form, and now we're switching to double intercept form. Okay, so for this one, we're going to have to go ahead and move the 4 over. So let's do that first. 2x minus 3y equals negative 4, because we're subtracting 4 from both sides. And then if you recall for this one, it's supposed to equal 1, not negative 4. So now we're going to divide everything by negative 4. Okay. This gives us negative. Okay, we don't normally do this, so I'm going to go ahead and keep the negative on the bottom. So I basically have x over negative 2 when we reduce this. And then a negative divided by a negative, so this is plus 3y over 4, and that equals 1. But if you take a look at what this form is supposed to look like, it is x over the x-intercept plus y over the y-intercept equals 1. Our y isn't by itself. Okay, so we need to fix that. So what we're going to do to that fraction is, and I'll just write on the side because I didn't leave a gap here. What we're going to be doing, okay, we have this. We need that 3 to not be there. So we're going to multiply this fraction by that fraction. Because when we do a third of 3, that's 1. And we'll just have one y on the top. So this 3y over 4 is equivalent to y over 4/3. This is one case where you are allowed to end where your answer has a complex fraction. You have to for this sometimes. X over negative 2 plus, again, that's simplified to y over 4/3 equals 1. This is the double intercept form. To graph the line using this, we'd put a point at negative 2 on the x and do our best to put a point at 4/3 on the y and connect them, because that's the x-intercept and this is the y-intercept. That is what they asked us to do. We're done with the notes. Have fun manipulating linear equations.